Hello everyone, welcome to this talk where I'll talk about how state management can be simplified using Zustand. I am Sai Eashwar and I'm currently an app developer exploring React Native and I work at Grow simplifying finance for all. Before we begin the talk, a quick disclaimer about what this talk is going to be about and what it's not going to be about. In this talk, I'll give a quick walkthrough of how we used to split Redux Saga into multiple substores. Then I'll talk about what were the problems we faced with Redux Saga and then why we are switching to Zustand and how we created some Zustand utilities which will help other developers use Zustand in our code base. What this talk is not about, this talk is not a comparison of all the state management libraries, and this is not a comprehensive review of either Redux or Zustand, and this is not the ideal state management solution for all the applications. With this disclaimer aside, let's just begin. We have been using Redux Saga since the beginning throughout our application, and having used it for so long, we did face some problems. Now, before coming to the problems, I'll show you how we used to split Redux Saga into multiple substores. Here's a contrived typical blog example. Suppose our blogging app has two features, blogs and account details, and we want to split our Redux store into two substores for blogs and account details respectively. Let's see how we can do that. So the first thing is we'll define the type of the state. So in this example, the state has blogs, which is an array of blogs, and then a couple of flags, fetching blogs and fetch blogs error, which are Boolean. One more quick disclaimer. Some libraries like server state management libraries like React Query make it much simpler, but this is out of the scope of this example. And this example is just to prove my point of the problems we used to face with Redux Saga. Next, we define the initial state. In this example, blogs would be an empty array, and these two flags would be false initially. Then we define the actions. Actions are basically objects which tell which reducers must be executed. We used to use a library called Redux Source to set up our Redux store. This exposes a function called create actions, using which we define the actions where we define the payload as an array of strings, right? And then we have to define the different reducers. Reducers are the functions only through which we can update the state, right? So we have three reducers: fetch blog success, fetch blogs error. In fetch blocks, we basically update the flags, loading flag to true, error flag to false. And in fetch block success reducer, we accept blogs in the payload and we update the state with the blogs and we make the loading flag to false. And in the fetch blocks error reducer, we update the flags respectively, that is loading to false and error to true. Redux source produces action types which are screaming snake cases of the actions we defined earlier. For example, for this action fetch blogs, the action type would be fetch blogs but in screaming snake case. Here we are mapping the action types to our reducers and creating the reducer. Then we have to define sagas. Sagas are side effects which we want to run whenever a particular action is dispatched. And these are generator functions and we can run asynchronous logic inside them. So whenever we dispatch fetch blogs action, we want to get the blogs from the API and then set it in the state. So what this saga does is it makes the API call, it makes the API get call, and if the response is all right, we dispatch the fetch blog success action along with the response data as a payload. But if the API was failure, then we dispatch the fetch blogs error action. Next comes watchers. Watchers basically watch for action dispatches, and if any saga is tied to a particular action, then it forks that saga. So here basically for this action type fetch blocks, we are telling Redux Saga that whenever fetch blocks action is dispatched, we want to execute this saga. We want to fork this saga. So watcher basically forks this saga. Now we saw how we created the substore for our blogs feature. Similarly, we create the same for account details as well. And in our root reducer, we combine those reducers. And we create one saga in which we just instantiate all the different watchers of all the multiple substores. Then we create the root store We define any middlewares. Here we are creating using the create saga middleware. There can be other middlewares as well, and then we use those middlewares in the enhancers, and then we create the store. We also execute this saga here. So that was how we used to split Redux Saga store into multiple substores for each individual feature. Now I'll quickly tell the problems we used to face with Redux Saga, and hopefully after looking at the example, you too can relate with these problems. The first problem is that the mental model of Redux Saga is quite complicated. It's not simple. Especially for newcomers, understanding how Redux Saga works and getting comfortable with it takes a lot of time. Next is boilerplate. Redux Saga introduces a lot of boilerplate. We divide our code base into multiple containers. A container is basically a product which we ship in the app. For example, mutual funds, stocks, etc. And each of these containers can contain multiple features as well. And we try to keep these features as modular as possible. So as you can see, feature A has its own components, screens, services, and a store. Similarly for feature B. Now using Redux Saga, like we saw in the example, we have to define actions, reducers, sagas, watchers, etc. for each feature. And then we have to combine all the reducers of all the features of that container. And then also in the root store, we have to combine all the reducers of all the different containers. So this introduces a lot of boilerplate, and this doesn't fit that well with our modularity principle. Next, like we said, we were using Redux source library. There were many problems using Redux source, which mainly boiled down to having poor type support. For example, when we were defining the actions, we pass the payload as an array of strings, but there's no provision to give the type for this payload, right? And even when we are mapping action types to reducers, there's no autocomplete, auto suggestion, etc. And it becomes very easy to create typos here. Moreover, even while dispatching the actions, due to lack of type support, passing payload becomes very hard. Some of these problems aren't Redux problems per se. We could use a better library like Redux Toolkit. But we still wanted to explore alternatives and see if there are any other easier libraries. Then we came across Zustand. The first thing which I remember when I came across Zustand was how simple it was to read its README and then set up a store within a couple of minutes, right? So we wanted to create a POC for Zustand, and we actually used it in one of our features, right? And we started liking it, and so we enumerate. I'll enumerate all the advantages we found with using Zustand, and we also created some utilities which will help other developers use Zustand in our code base. The first advantage, like I said, is simplicity. There is no complex mental model like Redux. There are no actions, reducers, sagas, etc. It's almost like a regular JavaScript object. You can have all the state values as well and functions within the state. And these functions can be asynchronous as well. Hence, we don't need Saga. Right? Then Zustand provides something called transient updates, where you can listen to state changes without causing the component to re-render. For example, it's a very simple pattern where we use a ref to store any state value, right? And Zustand has a method called subscribe, and the callback which you pass will be executed whenever the state is changed. So in this callback, we just change the current value of that ref to the updated value. So in this way, suppose in your particular use case, you do not want to cause many re-renders for state changes. This might be very performant in those particular use cases. Then Zustand, there's not a lot of boilerplate. Zustand fits quite well with our modularity principle. Each feature can have just one slice file, right? There's no need of multiple files. There's no need to combine multiple stuff. Nothing. Each feature can have their own slice, and this also gives that feature complete ownership, complete customizability of their state. So those were the advantages. And after looking to the advantages, we thought we should continue using Zustand, and we created certain utilities which will help other developers use Zustand in our code base. The first one is resettable slice. Many a times we would want to reset a slice back to its initial state, but currently Zustand doesn't provide any method out of the library. There are a couple of ways to solve this. One is to use a simple pattern. So in this pattern, you define the types of state separately and then actions separately. Actions are basically the functions in which you want to update the state, right? And in these actions, we'll have one function called reset. Then we define the initial state separately without the functions. And then when we are creating the slice, we just spread the initial state. We define the actions, like we define these two functions. And then what this we define a reset function so that it will update the state to its initial state. So using this, whenever you want to reset your slice, you just do use slice dot get state dot reset if you're using it outside a component. But we also came across a scenario where we have to reset multiple slices at once. For example, if a user logs out, we might want to reset all these slices, right? So in that case, we shouldn't expect each slice developer to call the reset callback in a particular file. So we created a function called create resettable slice. So this accepts a name, which is a string, and the rest of the arguments is similar to the slice. The signature is almost the same as that of Zustand create. Right. So if the name is already, if a slice is using a name which is already used, then we'll throw an error. But suppose that is not the case. First, we use Zustand's create method to create a slice. We get the initial state using the get state method of Zustand. Then we define a resetter for that slice. Resetter in our case basically contains the name, which is the name of that slice, and a callback, reset callback. What this callback does is it just updates the state to the initial value, which we got here, right? And then we also store all these resetters in an array. Then we return the slice which was created. This reset slice method accepts a name, which is the name of the slice you want to reset. So we loop through the array and then find the particular resetter and execute the reset callback. And suppose you want to reset all slices at once, then we loop through the entire array and execute each and every reset callback. One more suggestion here is, suppose you do not have the requirement to reset individual slices. Then we can get rid of this name argument and then keep the signature exactly the same as that of Zustand's create. So this is about resettable slice. Next comes rehydration. So suppose you are persisting your Zustand state and the storage you are using is asynchronous. Then the process of reading the state from memory into your Zustand slice is asynchronous and it takes some time. So this time is called rehydration. In your app, for example, when the state is rehydrating, you might want to show a loader. For example, in app.js, you might have, if state is rehydrating, show a return loader, otherwise proceed further, right? Now, since we are promoting modularity, there could be multiple persisted slices. And if we want to show this loader, then every individual slice developer should remember that, okay, his slice is persisted, he has to handle rehydration, and then he has to come to this file. And there might be a big condition like if feature A is rehydrating or feature B is rehydrating or so on, a return loader or else proceed further. Then he'll have to extend this condition and make it even bigger. We do not want this, right? So we thought we'll create one separate slice. This contains rehydration statuses of all the persisted slices. So now in the place where we're showing loader, we just read the value from that, we'll read a single value from that particular slice and decide if you want to return a loader or proceed further. So that slice I was talking about is called useZustandRehydration. What exactly does this slice contain? One, it contains a value called all slices rehydrated, which is a boolean. This tells, as the name suggests, if all the persisted slices are rehydrated or not. It contains an object, rehydration statuses. This is a key value pair where the key is the name of the slice and the value is the rehydration status of that slice. Then there's a method called add slice, which accepts a name, which is the name of the slice. And then there's a method called update rehydration status, which accepts the name of the slice and then the new rehydration status value of that slice. So what add slice does is it adds that particular slice into this rehydration statuses object. And whenever update rehydration status function is called, the rehydration status of that slice is updated. And then we check if all these slices are rehydrated or not, all these slices in this object. And then we update the value of all slices rehydrated accordingly. And one more small thing to note is the default value of all slices rehydrated should be true. This is because it might just be the case that there are no persisted slices at all. In that case, it means all slices are already rehydrated. There's no need to show a loader, etc. So this is the implementation of the comments I showed in the previous slide. Add slice, what it basically does is it adds the new slice into the rehydration statuses object, right? And again, by default, the rehydration status is true. And update rehydration status, it basically updates the rehydration status of that particular slice. And then we check if all the slices are rehydrated. Here we are looping through this rehydration statuses object, and if all the rehydration statuses are true, then all slices rehydrated will be true, otherwise it will be false, and the updated value is stored. So this is useZustandRehydration. I'll also show you how this is actually used in another utility in a short time. Next comes persist. Zustand provides a middleware called persist, which helps in persisting our state to memory. Right? There are multiple options, but we thought we should provide default behavior to three of those options. So one is get storage. Get storage basically tells Zustand which storage to use for persisting. Then another option is on rehydrate storage. On rehydrate storage is a callback. This gets executed when rehydration is about to begin, before the rehydration begins. And this callback, it can return another callback, and the returned callback is executed when rehydration is completed. So before rehydration begins, this callback is executed, and the return callback is executed after rehydration is completed. And then there's another option called partialize, where we can tell Zustand what parts of the state to actually persist. So this is the persist wrapper. The signature is exactly the same as that of the persist from Zustand middleware. And I've commented what this wrapper basically does. So first thing is we add the slice to useZustandRehydration. We use the add slice method. And then by default, we set the storage as async storage. On a quick side note, we are exploring better synchronous alternatives. But in this example, we are setting async storage as a default storage. Then we define a default on rehydrate storage behavior. So what this does is when rehydration of this slice is about to begin, we set the rehydration status to false in this slice, in the useZustandRehydration slice. And then the developer might have defined his own custom on rehydrate storage logic. We execute that as well. And if the developer has returned any callback, we store that. And once rehydration is completed, we update the rehydration status of this slice to true. And if the developer had returned any custom callback, we execute that as well, right? And coming to partialize, when we are persisting, we're basically stringifying the entire state and storing it in memory. So, and since in Zustand we store all the state values and functions together, it doesn't make sense to stringify the function as well. It just takes unnecessary space. So by default, we want to store only non-function values. So that is what this partialize does. And then we use these updated default options and use the persist from Zustand middleware and return the persisted slice. Now I'll quickly show the implementation of each of these comments. They're pretty small and simple. So first is, like I said, we have to add this slice to useZustandRehydration slice. So we are doing that here and we're passing the name. And here we are defining async storage as a default storage. Next, let's come to on rehydrate storage. First, we check if the developer has defined his own on rehydrate storage. We store it in a variable here. And then when before rehydration is about to start, we'll update the rehydration status to false, right? And then if the developer has defined his function, we call that as well before rehydration begins. And then if he has returned any callback, if the developer has returned any callback, we'll store it in custom after rehydration. And once rehydration is completed, we update the rehydration status to true. We are telling the slice has been rehydrated. And if the developer had returned any custom after rehydrate callback, we execute that as well. So this was on rehydrate storage. So this is how we are using the previous slice which we created inside another wrapper which we created. Next comes partialize. So like I said, in partialize, we basically loop through the entire state. And if the type of the value is function, we don't do anything. But if it's not a function, we append it to one variable called state to store, which is as an object, and we return this object. This returned object gets persisted in the memory. So these were some of the utilities we created, which we thought might be helpful to others. So the next time a developer wants to create a persisted slice, he need not worry about most of the default behavior. Yeah, it's already handled. So that was it for my talk. I explained how we used to use Redux Saga to split into multiple substores, and hopefully you could relate to the problems we faced, and then why we think Zustand is a good alternative, and how we created some utilities to help others use Zustand in our code base. So that is it for my talk. And if you have any questions, I'll be glad to answer them. Thank you.